Right, in this video, we're going to talk about suggested homework problems from section 5.5. This will be differentiation and integration of exponential functions with bases other than e. So let's start off with number one, and our derivative formula for a to the u is going to be ln of a times a to the u times u prime. They've written that in the form of a ln of b times 6 to the 4x because they know u prime is going to be a constant here. So if we take d dx of 6 to the 4x following our formula, we have ln of 6 times 6 to the 4x times 4, and we'll rewrite that as 4 ln of 6 times 6 to the 4x, and they want us to call this a times ln of b times 6 to the 4x, and they want us to identify a and b. So a is 4 and b is 6. Look now at number 3. One of the things that we'll do in this section is something called logarithmic differentiation. So when is it necessary to use logarithmic differentiation to find the derivative of an exponential function? That's going to be when we have our variable that's changing in both our base and our exponent. So something like, but not only like, y equals x to the x. It could really be any base of a function of x to any base that is a function of x, or if you prefer, u's and v's to f's and g's, because the left-hand side could be f and g, then something along those lines. So when you see an x in the base and an x in the exponent and you want to find the derivative, we're going to have to use logarithmic differentiation. All right, some reviews, some review of log properties. Once again, log base 7 of 1, log base anything of 1 is 0. Number 9, log base 64 of 32. 32 is not a power of 64. Both are powers of 2, though, so I can use my change of base formula to write log base 2 of 32 over log base 2 of 64. And since 32 is 2 to the 5th, this is 5. 64 is 2 to the 6th, so that's 6. 11. We are to rewrite 2 to the 3rd equals 8 with logs. That's log base 2 of 8 is equal to 3. And then that was part A. Part B says 3 to the negative 1st is equal to 1/3. So that means log base 3 of 1/3 is equal to -1. (13) says a log base 10 of 1/100 is equal to -2. So when I rewrite that, 10 to the -2 is 1/100. Part B, log base 1/2 of 8 is equal to -3. So 1/2 to the -3rd is equal to 8. All right, I'll do my best to sketch a graph. I'll also use the calculator to show you a better version of the graph that I'm sketching. So y is equal to 2 to the x will be exponential. It's going to go through 0, 1, 1, 2, 2, 4, -1, 1/2, -2, 1/4, and it's going to have a asymptote on this side of y equals to 0. Going to grow exponentially. So 2 to the x and zoom 6. And it'll look like that. If you want to see the points that I was just talking about, there they are: -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. These are all the powers of 2 here. That will be your ordered pairs. Okay, let's look at number 17. We can look at it 2 different ways. Y is equal to 1/3 to the x. That's the same thing as 3 to the -1 to the x, or 3 to the -x. So if I don't like fractional bases, I can look at it with the base of 3, and then I have to do a reflection across the y-axis. It'll give me the same answer. Both are going to go through 0, 1, either way I look at it. To the first power is going to be 1/3. To the second power is going to be 1/9, which is even closer. So my y equals 0 is horizontal asymptote is on that side. At -1, I'll have 3. At -2, I'll have 9, 5, 6, 7, 8, 9. It's way up here. And then this is going to be an exponential decay function as I go left to right. Like so. All right, 19. I guess I should show you this one over here. 1/3 raised to the x. And there it is. All right. I'll show you what I was saying, that I'll graph it in red. 3 to the -x is exactly the same thing, and the red will trace right over top of the blue. All right, 19. H of x is equal to 5 to the x minus 2. Again, we can do this with transformations, which is how I'm going to do it. If you wanted to rewrite this as 5 to the -2nd times 5 to the x, this is 1/25 times 5 to the x. And you could look at that as a vertical compression. I'm going to look at it as a horizontal shift to the right. So instead of going through 0, 1, we're going to go through 2, 1. And I'm going to treat that like my new 0 of my function. So 1 to the right of there, we're going to have 5 to the first power will be 1, 2, 3, 4, 5. And then 1 to the left of that, there will be 1/25th, which is way down here. And this just grows so fast. I'm not going to try to graph 25, but it's going to have a horizontal asymptote over here on this side. And it's just going to take off, grow really fast that way. And it comes down really quickly to this horizontal asymptote down here. And there's a lot of, like we said, vertical compression that happens here. All right, 21. 21 asks us to solve for x, and we're only going to do 21 part B. Log base 10 of 1/10 is equal to x. So this is the same thing as log base 10 of 10 to the negative first. It's equal to x by our log properties. X is equal to -1. Let's look at 23. Again, part B. Log base 2 of x is equal to -4. X is equal to 2 to the -4th, or 1 over 2 to the 4th. So 1 over 16. Now let's look at 25B. T5B is 3x plus 5 is equal to log base 2 of 64. So 3x plus 5 is equal to log base 2 of 2 to the 6th. So 3x plus 5 is equal to 6. Subtract 5 from both sides. 3x is equal to 1. Divide by 3. X is equal to 1/3. And now let's look at 26B. Log base 10 of x plus 3 minus log base 10 of x is equal to 1. So use my log properties here to combine these into a single log. And then x plus 3 over x is equal to 10. I'm going to pay attention to my domain here and say that x has to be greater than 0, just so I don't accidentally give a extraneous solution here, because both of these logs have to have positive arguments to start off with. Let's multiply now by that denominator, and let's subtract x from both sides. 9x is equal to 3. Divide by 9. X is equal to 1/3. If that's the case, let's just check this. So log base 10 of 10/3 minus log base 10 of 3 to the -1st will be log base 10 of 10 minus log base 10 of 3 plus log base 10 of 3, and log base anything of itself is 1, which is what that should have been. So that's correct. Let's look now at number 27. And these require the calculator. 3 to the 2x is equal to 75. So 2x is equal to log base 3 of 75. Now, if you have a fancy calculator like me, then you'll have a log base anything button in your calculator. Most people that have scientific calculators or even graphing calculators don't have that. So I'm going to use my change base formula here and use only the ln and log buttons here, because I know everybody has them. So ln of 75 divided by ln of 3, and we'll approximate this to be 3.9. What did I do wrong here? Oh, I still need 2x is approximately this. So I need to take 1/2 of that. Very good. So divide that by 2. That's better. 1.965. That was 27 and 29. I'll just show you how to do this. Again, you'll need 1/2 or 0.5 times, and then in your math menu, you have a log base here. If you have a higher later operating system, TI-84. It's not on the 83s. It's not on the early 84s. It's only on the later 84s. So there you go. You get the same answer. It just does the change of base formula behind the scenes. So we could also solve that with graphing. So another way I like to solve these sometimes. This one's kind of big to do this with, but 3 to the 2x on one side of the equation, 75 on the other side of the equation. And their solution is going to be where the two functions cross each other. I'll hit zoom 0 to try and zoom fit. And I want second calc 5 for intersection between the red and the blue. And it's going to intersect right there at 1.965. So a couple of different ways you can solve these. Sometimes graphing is the only way to solve these. All right, so ln of 2 to the 3 minus x is equal to ln of 625. That's 3 minus x equal to ln of 2, or times ln of 2 is equal to, this is 5 to the 4th, so 4 ln of 5. 3 minus x is equal to 4 ln of 5 divided by ln of 2, and then x minus 3 is equal to negative 4 ln of 5 over ln of 2, and x is equal to 3 minus 4 ln of 5 divided by ln of 2. So 3 minus 4 ln of 5 divided by ln of 2 is a negative 6.288. Let's look at 31. 31 looks like something out of accounting with continuously compounded interest, something like that, or not continuously compounded, but compound interest. So what that looks like, a 9% interest rate for compounded monthly for T years. We want to see when our principal is going to triple, something like that. So So 12t ln of, and I'll call this 12.09 over 12 is equal to ln of 3, and t is equal to ln of 3 over 12 ln of 12.09 over 12. So this is ln of 3 divided by parentheses 12 ln of 12.09 divided by 12. Close the log, close the denominator. We get 12.253 for our t. Let's move on to number 39. Let's find the derivative now. F of x is equal to 4 to the x. F prime of x is going to be 4 to the x times ln of 4, and I'll just write the ln of 4 out front. If you want to break this down some more, since 4 is a composite number, you can call that 2 times ln of 2 times 4 to the x, but really there's no advantage to doing that here. I might do that sometime later in the problem set if it helps me cancel something out. So f of x is equal to x times 9 to the x, so u is equal to x. V is equal to 9 to the x, so u prime is 1. V prime is ln of 9 times 9 to the x. And so f of x is u times v. So f prime of x is u prime v plus v prime u. F prime of x is 1 times 9 to the x is 9 to the x plus v prime times u is x ln of 9 times 9 to the x. They'd love to pull the exponential part out here in their answers, like so, and leave it factored like that. One of the reasons for that is because when we're doing derivatives, we want to see when they're equal to 0. That exponential part is never going to give me 0 because it has a horizontal asymptote of 0, unless I've shifted it up or down. But usually this will just shift it left or right at most, because it'll have something up here plus or minus with this x. And so I'm usually looking at the 0 of this factor here, not considering what's going on with the exponential when I'm looking for zeros of the derivative. All right, let's look at 45. Is going to be the quotient rule. F of t is equal to -2t squared over 8t. So u is -2t squared. V is equal to 8t. U prime is a -4t. V prime It's ln of 8 times 8t, and f of t is u over v, making f prime of t u prime v minus v prime u all over v squared. F prime of t is a negative 4t, 8 to the t minus a negative 2t squared times ln of 8 times 8 to the t over v squared. So 8 to the t times another 8 to the t. And I see that 8 to the t, which is non-zero, is common in everything that will divide out. So f prime of t, it's a negative 4t plus 2t squared times ln of 8 over 8 to the t. And so the book, like me, likes to write subtraction when one term is positive and the other term is negative. And because we're probably trying to think about when is the derivative 0 here, it wouldn't be a bad idea to factor out this common factor of t. Maybe this 2 as well. Like so. So that would help me set this other factor equal to 0. And it would be kind of obvious that t equals 0 would also be a critical number here. That was 45. Let's look at 53. 53 says y is equal to log base 5 of square root of x squared minus 1. So y is equal to 1/2 log base 5 of x squared minus 1, which x squared minus 1 is the same thing as x plus 1 times x minus 1. Let's see, do I want to break all that up? I think I'll leave that inside of that log alone for right now, but I don't want to deal with the square root, so I'll take the square root out. So y prime is 1/2 of, and then I don't think we talked about derivative of this. So log base a of u is going to be 1 over u. Ln of a is in the denominator times u prime. So u is down here. Ln 5 is down there. U prime is up here. 2's will cancel, like so. And y prime will be x over ln of 5 times x squared minus 1. Let's look at 59. 59 says g of t is equal to 100 is equal to 10 log base 4 of t over t. So this is a u over v situation. u is equal to 10 log base 4 of t, v is equal to t, u prime is 10, and then times 1 over t times 1 over ln of 4, and v prime is 1. Now it will help me here because I have a common factor of 2 to write that ln of 4 is 2 ln of 2 times t, and that 2 will go into that 10 5 times, leaving me with 5 over ln of 2 times t for my u prime. So g prime of t is u prime v minus v prime u all over v squared. G prime of t is 5 over ln of 2 t minus times t, the t's cancel here, minus v prime times u all over v squared. So g prime of t is 5 over ln of 2, and I need to use my change of base formula here to write this 10 ln of t over ln of 4, and that is all times 1 over t squared. G prime of t is 5 over ln of 2 minus 10 ln of t over 2 ln of 2. This is 5 over t squared. 5 comes out. 5 over t squared. 1 minus ln of t over ln of 2, and times 1 minus ln of t over ln of 2 times t squared. That's what g prime is. Let's look at 63. 63 asks us to find the equation of the tangent line. Tangent to the curve y is equal to log base 3 of x at the point 27, 3, which is on that curve, since 3 to the third is 27. So y prime is equal to 1 over x times ln of 3. Y prime at 27 is going to be 1 over 27 ln of 3. So that's my slope, and this is my point. Y minus y1 is equal to m times x minus x1. Y minus 3 is equal to 1 over 27 ln of 3 times x minus, and then the 27s will cancel, 1 over ln of 3. Y is equal to 1 over 27 ln of 3 x plus 3 minus 1 over ln of 3. Let's look at 65. Y is equal to x to the 2 over x. So this is one of those examples of x in the base, x in the exponent. We need to use logarithmic differentiation here to find dy dx. So ln of y is equal to ln of x raised to the 2 over x. So ln of y is equal to 2 over x, ln of x. And I have derivative on the left is 1 over y times dy dx. Derivative on the right, we'll use the product rule, where u is equal to 2x to the negative first. U prime will be a negative 2x to the negative second. V is equal to ln of x, and V prime is 1 over x, or x to the negative first. So u prime v, negative 2x to the negative second, ln of x, plus v prime u, 2x to the negative second. And then I have dy dx is equal to y times, and I'll pull out my common factor of 2x to the negative second here, 1 minus ln of x, and y is equal to x to the 2 over x. We have a 2, and we have times we have a common base, so I'll add the exponents. So 2x to the 2 over x minus 2, 1 minus ln of x. All right, let's look at number 69. Integral of a to the u du is equal to a to the u over ln of a plus c. So this is going to be 3 to the x over ln of 3 plus c. 71. Integral of x squared plus 2 to the negative x dx. Integral of x squared plus integral of 2 to the negative x dx. I need -1 and a -1 here. This is 1/3 x cubed. This will be minus 2 to the negative x over ln of 2 plus c. So look at 73. Integral of x is 5 to the negative x squared dx. My u is a negative x squared. My du is a negative 2x dx. So -2, -1/2. This is -1/2 times 5 to the negative x squared over ln of 5 plus c is a -5, negative x squared over 2 ln of 5 plus c. It's 75. 3 to the 2x over 1 plus 3 to the 2x dx, u is equal to 1 plus 3 to the 2x. So u prime is 3 times 3 to the 2x times 2 is 2 ln of 3 times 3 to the 2x dx. So there's my constant multiple that I need right there for du. So 2 ln of 3 on the inside, 2 ln of 3 in the denominator on the outside, 1 over 2 ln of 3 times ln of the absolute value of 1 plus 3 to the 2x. Now, exponential functions are going to always be positive, and if I add 1 to it, it's always positive. So I don't need absolute value bars here. So this is ln of 1 plus 3 to the 2x divided by 2 ln of 3 plus c. Number 77. This will be a definite integral instead of an indefinite integral. Negative 1 to 2 of 2 to the x dx. So that will be 2 to the x over ln of 2, evaluated from negative 1 to 2 is 1 over ln of 2, 2 to the second minus 2 to the negative first. It's 1 over ln of 2 times 4 minus 1/2 is 1 over ln of 2. 8 halves minus 1/2 is 7 over 2 ln of 2. It's 79. Zero to 1, 5 to the x minus 3 to the x dx. 0 to 1, 5 to the x dx minus 0 to 1, 3 to the x dx. It's 5 to the x over ln of 5, 0 to 1, minus 3 to the x over ln of 3, from 0 to 1. It's 5 minus 1 over ln of 5, minus 3 minus 1 over ln of 3 is 4 ln of 5 minus 2 over ln of 3. And that's good enough for me. Let's look at number 99. 99 says that the yield be in millions of cubic feet per acre for a stand of timber at age t is given by the equation capital V is equal to 6.7 e to the negative 48.1 divided by t, where t is measured in years. Find the limiting volume of the wood per acre as t approaches infinity. So limit of v as t approaches infinity is equal to limit as t approaches infinity of 6.7 e to the negative 48.1 divided by t will approach 6.7 e to the 0 is 6.7, and that's 6.7 million cubic feet per acre. There. So that's our limit. E as t goes to infinity is equal to this. All right, that was part A. Part B asks us to find the rates at which the yield is changing when t is equal to 20 and t is equal to 60. So let's find dv dt, and that is 6.7 e to the negative 48.1 divided by t times the derivative with respect to t of negative 48.1 t to the negative first. So that is dv dt is 6.7 e to the negative 48.1 divided by t times a negative is a positive 48.1 t to the negative second. So let's write this here as dv dt is 6.7 e to the negative 48.1 divided by t times 48.1 over t squared. And I'll leave it just like that. There's really no reason for me to simplify because I'm going to be plugging this into the calculator to evaluate it anyway. So I'll just plug it in here, 6.7 e to the negative 48.1 divided by, and I'll use x's instead of t's, times 48.1 divided by x squared. And then table settings I'll set to ask because I only want this for a couple of x values here, specifically when x is 20 and when x is 60. So we'll say v prime of 20 is approximately 0.073, and those would be millions of cubic feet per acre per year. They don't give the units in the book, but millions of cubic feet per acre per year would be my units there. V prime of 60 is approximately 0.040. Again, millions of cubic feet per acre per year. Moving on now to number 115. We're given y of x is equal to x to the y. And so we want to find y prime. So ln of y to the x is equal to ln of x to the y. So x ln of y is equal to y ln of x. And differentiate both sides. So derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone. And then derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone, like that. And let's get my y prime pieces together on the same side. And my other pieces on the other side. Then I want to factor out y prime. Then y prime is y over x minus ln of y over x over y minus ln of x. And I would like to multiply by xy over xy here to get rid of my denominators. And y prime is equal to y squared minus x y ln of y over, and then this is going to be x squared minus x y ln of x and I'll just pull out the common factor of y here, y minus x ln of y, x times x minus y ln of x. Okay. And then I want to be able to evaluate this here at any point where x and y are the same. Well, if I do that, first c can't be 0 because I can't have 0 over 0, but also I can't have both of these things be 0 either. So if x were, let's see, I think 1 also gives me a problem here. Yes. So if I had 1 minus, no, not 1, let's see, E gives me a problem because if I have E minus E ln of E over E minus E ln of E, ln of E is 1, E minus E is going to be 0, and I would get 0 over 0. So C can't be 0, C can't be E. other than that, C can be anything else. And if that happens, then we have C times C minus C ln of C over C times C minus C ln of C. And I should have just done this. C squared 1 minus ln of C over C squared 1 minus ln of C. Those would cancel as long as C isn't 0. 1 minus ln of C can't be 0. So ln of C can't be 1. So C can't be E. That's where I get those two restrictions. And then this would cancel, and that would give me 1. So it equals to 1 as long as C isn't 0 or C isn't, and C isn't E. All right, let's look at part B. Looking at this form right here at 2, 4, that'll be 4 minus 2 ln of 4 over 2, and then 2 minus 4 ln of 2. All right, so this is going to be one of those times where maybe changing ln of 4 into ln of 2 is going to be helpful. So 4 times 4 minus 4 ln of 2 over, I'll pull the 2 out here, 4, 1 minus 2 ln of 2. So this is 16 times 1 minus ln of 2 over 4 times 1 minus 2 ln of 2 is, that's 4. And I have, let's estimate that in the calculator since that's exactly what I have. 4 times 1 minus ln of 2 divided by 1 minus 2 ln of 2. And this is approximately negative 3.1774. Let's look at C. C now wants me to switch this to 4, 2. So that's going to be 2, 2, 4 ln 2 over, well, okay, if x and y switch, these are just reciprocals. So really the easiest way for me to do this is just to take this one and raise it to the negative first power, because when I switch x and y in my formula here, that the numerator becomes the denominator and the denominator becomes the numerator. So that's just the reciprocal. So this is going to be negative 0.3147. And look at that and see that the inverse when I switch x and y here is going to be the reciprocal of the original. So I just took the reciprocal of my previous answer. All right, that's it for this video, and we will come back next time and we will talk about 5.6, which is going to be L'Hopital's rule. Yes. So see you for the next video.